Originally founded in 1979, Thermafin is now owned and operated by AET, a manufacturing firm that has the distinction of producing the world's finest and most efficient solar collectors. AET's reputation for excellence is based on its exclusive, durable, high-frequency forge welding process and superior performance of its proprietary crystal clear solar selective coating. The crystal clear coating process begins with a copper strip coil being uncrated and loaded onto an industrial reel-to-reel coating line. The copper strip is then uncoiled into the coating line, where it is cleaned and prepped by running through a triple-stage pre-clean process. Stage 1 is a D-smut immersion solution that is an alkaline cleaning agent. Stage 2 is a galvanic electro-clean solution, making use of anodic cleaning procedures. Stage 3 is an immersion acid activator solution that allows the subsequent coating crystal clear to adhere to the copper strip. Once the copper is cleaned to plating quality, the crystal clear coating process begins to produce a bimetallic alloy absorption layer. The coated copper strip is then rinsed and dried, enabling the crystal clear coating to accept an encapsulant layer for protection and enhancement. The encapsulant layer is a ductile quartz sol gel solution deposited at room temperature. This encapsulant protects the selective absorption layer and further enhances the crystal clear absorption performance by as much as 3% over the bandwidth of 200 to 2500 nm. The coated copper strip then travels through a series of infrared heaters to dry, densify, and cure the product. The final process is analyzing and recoiling the coated product. Product analysis takes place via an online fiber optic spectrometer that provides real-time absorption data as the coated copper strip passes into the recoiler. The spectrometer analysis enables the operator ease in changing the line speed, plating amperage, or chemical bath additions. Once the copper strip is coated and removed from the plating line, it's then placed on the computer-operated inspection station that realigns or indexes the coil for the subsequent welding operation. During this time, the coated copper strip is physically and visually inspected for any defects in the coating. If a defect is found, it is manually cut out and the realignment process is resumed. The material is quarantined for a 48-hour curing period prior to welding. After the material is cured, the coated coil moves to the solid-state high-frequency forge welder. This piece of equipment was designed during the growth period of the American solar energy industry. The ThermaTool fin tube welding system operates under the trade name Thermafin and is unequaled in speed and reliability. This piece of equipment has recently been updated by AET from a vacuum tube welder running at 60% efficiency to a solid-state welder running at 78% efficiency, allowing for a smaller carbon footprint on the environment. Capable of welding speeds of up to 300 feet or 91 meters per minute, the welding line delivers a high-frequency 400 kilohertz for various tube sizes and fin widths. The weld zone is a minimum of 2 times the thickness of the copper fin, providing the most efficient heat transfer possible and ensures a deep molecular bond guaranteed for 30 years. Cross-sectional microanalysis shows grain structure throughout the weld zone without fractures or inclusions. The weld line consists of dual take-up towers powered by DC drives and controlled by a dancer servo to receive the 16-foot diameter rolls of welded product. A caterpillar drive section pulls the material through the weld head from the feed reels at the front of the machine. Straightening and shaping rolls precondition the tube for welding, while a set of reversing rolls apply proper tension to the fin. Power to the material is provided through the overhead conduit, which is encased in an aluminum guideway. The contacts are sacrificial, made of 95% silver and 5% alloy. Controls for the welder are solid-state inverters using power MOSFET switches. The 16-foot reels take up the welded material, and each reel holds up to 3,300 feet of welded fin tube, which is equal to 42 4x8 feet collectors in 11 minutes. The full reels are then moved from the twin receiving tower to the twin feed cut to length tower, CTL. This line requires a minimum of 2 skilled workers to operate. The CTL begins with the receiving tower, which uses AC drives and a feed switch, which controls a material payout to the line. First, the tube is straightened. The tube is then rolled to the center of the fin, and the fin is then corrugated to allow for increased surface area. This line also uses a caterpillar drive, to pull the material through a set of straightening rolls and feed it to the cutting and end-forming sections of the line. The line is controlled by an Allen Bradley PLC controller. The material is fed through creating a hump sequence that allows pressure on the fin tube to ensure that it reaches the end stop, which sets the desired length. The reed switch activates the control sequence. The drive is slowed to half speed, and while the hump section is in motion, and by timing, the cut sequence is activated. The saw cuts the material, which then activates the lateral feed sequence, where the material is released and moved into the next index station. In the lateral section, the dual end treatments are performed. They are the crop station, which cuts back the copper from the end of the part, and the skiving station, which removes the material from the end of the tube and re-rounds it. The material is then conveyed to the unload station, where the visual QC takes place and the final product is prepared for crating and shipping. The CTL, when set up, can produce up to 50 feet per minute or 300 absorber plates per shift. Using a pneumatic indexing machine, the headers are punched from the inside out to form a T. The holes are punched from one end to the other, moving along the tube at equal spaces. AET's auto braze machine is capable of brazing one 10-riser absorber plate per minute. The auto braze is equipped with adjustable brazing fixtures for various absorber sizes. Servo-driven torch heads allow the operator to enter the positions of the risers for brazing. The operator can then store these positions for repeated use. Placing the headers and riser into the desired fixture with the torch assemblies in place, the auto braze is ready. Rotating the brazing fixtures in place, the PZOs drop to ignite the dual torch heads. Once ignited, the torch heads advance to their pre-programmed positions and start the brazing process. Heating the riser tube and header pipe in an oscillating motion allows for even heat distribution around each joint. Pyrometers measure the torch temperature at the two parts and at the precise temperature the brazing alloy is applied. This repeatability assures that every absorber plate is the same as the last one by removing the once manual operation of an inconsistent flame and alloy. Once completed, the absorber plate goes to a pressure check table. The plate is placed on the rack, the headers are clamped, and then it's immersed in water under pressure. The air valves are open to release air inside the absorber while it's checked for leaks. Should air bubbles be present, the absorber is raised out of the water and any leaks are repaired. Again, the absorber is immersed in the water and goes through the same checking process to ensure the integrity of the absorber plate. Now that the absorber plate is complete, we will move into our fab shop, where we fabricate the necessary components to build the box that will house the absorber plate. The final assembly will take place back in the assembly plant. The collector extrusion is cut in the assembly plant by the miter saws to the appropriate sizes that we manufacture. The extrusion is also punched in the dies for assembly of the corners. All the battens are punched for assembly. Once the extrusion is prepared, it is then loaded on rolling carts to be transferred to the main assembly area. Collector mounting hardware is also fabricated in our factory. There are several types of mounting hardware that are used in mounting collectors. All the pieces are fabricated and packaged in-house. The next step in the process is to cut the back sheet to length. We purchase back sheet on coil at a predetermined width. The uncoiler is used to cut the back sheet to the appropriate collector length. With the extrusion and back sheet ready for assembly, we move to the final assembly plant, where we assemble an end frame and two side frames of extrusion. The back sheet is slid in. Next, we slide the sheet of polyisosonorant in and enclose the opposite end frame wall. At this point, the side insulation is installed to ensure a tight fit all the way around the collector. The frame box is now taken to the squaring table, where the back sheet is riveted in place. It's very important that everything is square to ensure that the glass and absorber plate fit to specifications. The absorber plate is then installed into the box. Silicone grommets, which are used as shock absorbers, are installed around each of the exposed headers, which allow the absorber plate to expand and contract without breaking a brazed joint. We do not use any solvents inside our collectors. Therefore, we manufacture a header shield to cover the bare copper. This process is done only for aesthetics and has absolutely no bearing on the performance of the collector itself. The high-T glass used in our process is exclusive to AET. It is our proprietary chemical composition designed to provide for the highest solar energy transmission. The glass is cleaned by the use of AET's Prestic stainless steel glass washer. The glazing is then layered on a table, where the EPDM rubber gaskets are installed. This gasket is a continuous U-channel with post-formed corners. The EPDM rubber has a 30 to 50-year design life, which gives us a weatherproof seal to protect from Mother Nature. At this point, the glass is transported and inlaid onto the collector, where it is inspected to ensure that the fit is good and snug.
Okay, good.
The glazing cap is then screwed into place. The screws and rivets that are used in our manufacturing process are all stainless with a black oxide coating to match the frame wall for aesthetics. Wood blocks are strapped to each header pipe extension of the completed collector. The collectors are then packaged individually for shipment to their final destination. AET manufactures a 4-foot by 10-foot collector for use in commercial applications, as well as 5 smaller sizes used in residential water heating and space heating applications.
Hi, I'm Tara Byram, Vice President of Marketing at Alternate Energy Technologies. As you have seen, AET is a full-scale American manufacturer with superior technology. We've been in business manufacturing flat plate collectors uninterrupted since 1975. Our proprietary manufacturing process allows us to offer thermofin fin tubes to OEM manufacturers both nationwide and abroad. We take great pride in being able to provide the highest quality products for hot water applications, both residential and commercial, in America today. We have over 30 collectors and 120 systems fully tested and certified. AET provides the most energy efficient and cost-effective way to heat water, and we look forward to the continued growth of the solar thermal industry.